Where does the problem come in? It's when they change the probability. So let's say we do the same problem. And we want to make a chart out for the probability of girls. I was just thinking we're right doing that. Let's do it this way. There. Probability of girls. I just have to write like a second grader. Probability of girls, and that means 0 girls, 1 girl, 2 girls, and 3 girls. And over here is basically the probability of that event happening. But in this problem, there is a medicine that's being used that changes the probability. Probability of a boy is equal to 0.52, or wrong direction. 0.42. And that's all they give you, and they want you to make a probability distribution. So take your calculators out and go ahead and fill out that chart. First of all, what's the complement of 0.42?
0.58.
All right, so the probability of a not boy or probability of a girl is equal to 0.58. Now you've got what you need to do your probability distribution. And if you can't do it, just mark it down as being a failure. Yeah, last night there was no good movies on. I ended up having to watch The Deer Hunter for about the 50th time. So that was no fun. So to start you off, what would 0 girls be? Boy, 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 right? So that would be point what raised to the 3rd power? 0.42 raised to the 3rd power. Somebody give me that number.
It's 0.74088.
0.74088. 0.741. Now, if we can do 3 girls that easy, or 0 girls that easy, what else can we do that easy? 3 girls. And what would that be?
I'm so sorry.
0.58. I'm supposed to go into hysterics right now, aren't I?
I was trying to put my calculator and my Pandora came on.
Let's see, what am I supposed to say? You're a failure. All right, what's 0.58 raised to the 3rd power?
0.195.
0.195. All right, now y'all do the middle two. You can see my sign over here.
I was trying to hit the calculator button.
I'm surprised mine hasn't went off. One girl means that there's 1 girl and 2 what? So that would be 0.42 raised to the 2nd power times 0.58 raised to the 1st power, and all that times 3, because there's 3 of those events that could happen. No sneezing in class. What is all that times 3? What does that come up to be? Okay, y'all doing it by hand or what?
307.
How much?
0.307.
0.307. Two girls would be what? 0.58 to the second power, Hubert. That's right, class. And one boy, 0.42 to the first power, times 3, because there's 3 events there happening. And what does that come out to be? 0.424. Right quick, add all those up. See what you get.
You're like 1.6 something.
Something's wrong then.
It's the first one that's not right. It's supposed to be 0.07.
I appreciate y'all setting me up for failure. Y'all suck. All right, so what's this one supposed to be?
0.07.
Okay, so add all those up, what do you get? That one, that one, that one, and that one. What do you get?
1.01.
1.00. So that's how you check yourself to make sure you haven't set somebody up for failure, like y'all did me. So your probability distribution for this guy would be probability of girls and probability of that event happening, and 0, 1, 2, 3, 0.07, 0.307, 0.424, and 0.195. And that is probability distribution. See, that's not too bad. But try to have a class do a probability distribution and not show an example first. People won't know what to do. Because you can't go by what they give you in the book, because you get confused. So now let's look at a problem that they're going to give you for homework. Because this is the hardest section out of chapter 5. What you got to do by hand. The rest of it's calculation. Let me find a test question that I'll give you. There it is. And they already done it for you. Now, oh my gosh, we got to find the mean and the standard deviation. How do you do that? Well, the mean and standard deviation, you remember in frequency distribution you had that big old huge intimidating formula with n times p of x times, or n times the summation of p times x, quantity squared, or something like that, minus p of x squared, or something, p of p times x, or whatever. It is a big old nasty looking thing. Over n times n minus 1, remember that? Well, you're going to do the same thing on this one, except it's going to be a whole lot easier. To find the mean of a standard of a binomial distribution, real simple. Where did my do-cheaper go? There we go. The mean of a probability distribution is equal to the summation of x times p of x over should be n, or the summation of x. Okay? And they should give you that as soon as you hit, help me solve this. There it is. Well, they don't, there it is. No, they don't give it to you, they just, well, you gotta get summation of p of x. Okay, find the summation of p of x. I had x in there, sorry. There we go. So that's, add all these up to check to see if it's a, it is x times p of x. They're checking it to see if it's a binomial distribution. So check it to see if it's a binomial distribution. Usually they give you a formula. See, they usually give the formula right here. Give you an example.
Can't do that one.
They didn't do it.
There it is.
There we go. Well, still not giving you the. No. Okay, so I'm going to have to give it to you. In your book, there is a list of formulas. Let me go ahead and get it for you, because I was expecting it to come up on the handy-dandy problem, but it didn't. It's in blue, usually. Okay, green. There they are. And that is the mean, the summation of x times p of x. I'm sorry. Let me just go ahead and give you the three that I'm going to use, because they give you 5 or 4. I'm going to use 5.1, 5.3, and 5.4. 5.1, 5.3, and 5.4. So 5.1 is the mean, which is x times p of x. And 5.3, what is that called? The variance, which we don't use very much. And then you take the square root of the variance, that gives you the what? Standard deviation. So let's take this problem that we were doing, wherever it went. There we go. Let's take this problem right here, and I'm going to put it in this Excel spreadsheet. And we'll do it on the Excel spreadsheet, so it will take up all the board. And make it big so y'all can see it. And I'll put it right here. There we go. Everybody good? All I did was copy and paste it, so y'all should be okay with that. Alright, so the first thing we're going to do is find x times what? X times p of x. I'll do the first one for you, 0. Take that and multiply that times, isn't it amazing how I did that in my head? Y'all just don't respond to anything, do you? There it is. And then what do you do to find the mean? Add those what? Add those up. And that is your mean. Now that's pretty simple. Now how do you find the variance or the standard deviation? Well, I really don't care about the variance, but the questions in the book may ask you to find the variance, so, or the homework may ask you to find the variance. So we're going to find the variance. So we go to our handy-dandy formula. What do we need that we don't have in the variance and standard deviation formula?
X squared.
X squared. So that means we got to make a column called what?
X squared.
Nothing gets right, y'all. Nothing. I'll do the first one for you. There you go. Now, we got to take x squared, and what we got to do with it?
Multiply times b.
P of x. Get that summation, and then subtract what?
Mean squared.
mu squared. So let's do that. X squared times P of x. And I'm going to separate it a little bit so you won't get confused. X squared times, X squared times P of x. So equals X squared times P of x. Now don't pick the wrong one. Make sure I don't. And get that sum. And now my variance is going to be equal to this minus what?
The mean
This what?
squared.
Squared.
You put equals.
Think you're smart, don't you, Mr. Ball? There it is. And of course, to find the standard deviation, raise that to the what? To the 0.5 power. And you feel good about yourself. Now, if I've got the mean and standard deviation, what can I make?
Probability distribution.
Or the normal distribution curves. I know that's what you meant. Okay? So let's do that. Let's just go down here, and our mean is equal to this guy. And what's 2 to the right? Take the mean and add what? Standard deviation, Hubert. That's right, class. And this plus standard deviation. And then what do we do to the left?
Subtract.
Subtract minus standard deviation. And equals this minus standard deviation. And there's your curve. So of course now you can say anything between negative 0.34 and 3.1 is normal. And this is what you were given. This is the probability distribution. Binomial, probability, whatever. That's your distribution right there. Well, let's try this again. There. Comprende? So, you need to be able to make a probability distribution, and then you should be able to find the mean and the standard deviation. So what was our mean on that one? Our mean is 1.382. 1.38. And we feel good about ourselves. Oh, look there. It's asking for the variance or the standard deviation. And the standard deviation is 0.86. Is it unusual for a family of 3 children to have only girls? Well, what is only girls? 0.09. What would this be in money? 0.098. What would that be in money? 10 cents. That's right, class. Y'all telling me y'all don't know that that's 10 cents? Yes? No? Maybe? Vanna, does that look like 10 cents to you? Thank you, Vanna. Okay, now what does that got to do with the question, Hubert? Well, what is this? What is this money-wise?
5 cents.
5 cents, which is a what? A nickel. All right? So less than a nickel would be unusual. What is this? It's a dime. So is it normal? Yes. Because if it's less than a nickel, it would be what? It would be unusual. Let me show you that because some of y'all, I don't think you got it because y'all are not talking, so I guess I need to explain it. But that could be either way in this class because y'all don't talk. So, empirical rule.
Jesus.
No sneezing, please. Empirical rule says that 95% falls within two what?
Deviation.
So 95% is normal. Now, if 95% is normal, what are these two guys out here?
Unusual.
Huh?
Unusual.
Unusual. Somebody tell me what the percentage is of unusual. 5%. Y'all just jump on in, you know, whenever y'all get the answer in your head, just blurt it on out. So that's 2.5 cents here, right? And 2.5 cents here, right? So, if you have something less than 5% or 5 cents, it would be what? Huh?
Unusual.
It'd be unusual. Anything more than 5 cents would dump it in where?
Normal.
In normal. You understand? Okay. Just shout it on out, you know. Whenever you get the answer in your head, just shout it on out. Y'all settle down. I'm not going to give you one like this on the test because that take you 15 minutes to do that one. I was going to try to find you one that'd be a good test question. Nope. I'll give Vanna that one. Let's see. No. Well, there, Mexicans. Talking about Mexicans, that's racist. Look at there. How many Mexicans they put on the jury? That's racist. Let's see. Okay? Try that one. First of all, check it because some of these homework problems, they're not a binomial distribution, so you need to check the right-hand side before you even start. All right, I'll blow it up a little bit for you. Vanna, I'm giving you the day off. Vanna's the one stealing my styluses in the morning. I know that's what it is. There you go. They already have done the binomial distribution for you, so you don't have to do that much. The directions say find the mean and standard deviation, so chances are they're going to ask you about if something's unusual or not. What time's class over?
9:25.
Just checking. See if y'all tell me the truth.
Priority 1 message coming in on secure channel.
I'll go ahead and do the roll. Keep the bureaucrats happy. Today's March the, yeah. Bailey,
Here.
Bolt,
Here.
Clayton, Coward. He's here. Escobar,
Here.
Barr,
Here.
Freeman,
Here.
Hammett, Harris,
Here.
Harvey,
Here.
Hayes,
Here.
Johnson,
Here.
Mullins,
Here.
Murray's here, Newton,
Here.
Poor,
Here.
Perdesi. Does anybody know Mr. Perdesi?
Sort of.
Sorta. Does he sit? Where does he sit when he see her?
Right there.
All right. If you see him, tell him I need to see him. Okay. Light skin.
Yes.
I think I know who it is. Okay. Robinson. Oh, let me check. See, all my Robinsons are here. 2 of them are here. I guess Mahogany's not here. Scarborough's here. Schuler,
Here.
Simpkins,
Here.
and Dennis. I didn't see Dennis. Smallwood. I don't see my other Vaughn either. Smallwood's not here, and Anna Vaughn's not here. Williams. Williams. No Williams. Wood. No Wood. I want to check. Let's see. You attendance for this class. I want to make sure I hadn't missed anything. They say this the day of attendance. Wednesday. Did I not take attendance Wednesday?
You always do.
Huh?
You
You
left
left early.
always do. You left early, so you're gonna mark everybody here.
I got a what? Okay. Well, I better just take attendance and y'all tell me if y'all are here or not. And I'll take it for the next couple of days, and that way I'll get everybody. They don't like it when we do that. They have a fit. We have people actually paid to look at attendance. They actually get paid salary to watch attendance.
That's
Yeah.
that job.
So what do they do whenever they look at it?
They just make notes if there any time that you have everybody here, you'll get an email to make sure you check your attendance. So if you have a good class and everybody shows up, that's not good.
But yeah, you have to.
Tri-County Tech is not. All right, this is Wednesday. Y'all just be honest, okay? I don't care if you want to hear or not. No big deal. Bailey,
Here.
were you here?
Yes, sir.
Okay. Bolt?
I was here.
Okay. Clayton? She ain't here, so I'm gonna say no, but she needs to tell me that it was warm. Howard? She wasn't here. Okay. Dutchke, were you here? You ain't gonna lie to me, are you? Escobar, were you here?
Yes, sir.
Farr? Freeman? You wasn't? Okay. Thank you for being honest. Hammett? No. Harris?
Yes.
You were here. Harvey?
Was not.
You was not? Okay. Hayes?
No, was not.
Loser. Johnson?
Yeah.
You were here. Mullins?
I was.
Okay. Murray, were you here?
Yeah.
Okay. Newton?
I wasn't.
You wasn't? Everybody laid out Wednesday. Poor?
Yes.
You were here. Perdesi, was he here? Don't know. Was Robinson's here?
I was.
here.
Okay, two of y'all was here. I don't know about Mahogany. I'll ask her tomorrow. Scarborough, were you here?
Yes.
Schuler?
I was here.
Simpkins?
Yes.
Don't know if Dennis was here. Smallwood? Don't know. Mr. Vaughn, I know you were here. You're always here. Williams? Don't know. And Wood? Don't know. I need to go over this tomorrow, no, Wednesday again, so y'all remind me to do that. I don't know if I'll be able to change it or not, but I'll try. Because the bureaucrats, they go over it and they'll seal it, so you can't go back in and change it. This is such a crime wave, you know, attendance. That's such a big crime thing now. Our federal government is really hunkering down on people trying to get over on their attendance in college, but our borders in north and south are open as. Glad our federal government is really prioritizing what's important. Did y'all catch any sarcasm there? A little bit?
Oh, yeah.
Okay.